Hello again, physicists. Today, I bring to you an installment of physics, and our topic for this installment will be average velocity. Let's get straight into it. For average velocity, v first off will be the symbol for velocity in general. And if we were to place a bar over the top of it, that's going to specify that it is an average velocity, like right there. And to find an average velocity, what you would do is you would determine your displacement, and then you would divide it by the amount of time that has passed during that displacement. And to expand further, that just means that we're going to take the difference in our positions to determine the displacement, and take the difference in time, or how much time has passed, for us to complete that displacement. It's important to note that with velocity, it has direction, just like displacement had direction associated with it. So let's try an example looking at average velocity. For our example, Mr. H takes his dog Buddy for a walk. From his house, they walk 2,000 meters west for 1 hour. What will their average velocity be in base SI units? Very well, let's get started. So I know that to compute that average velocity, it will be my displacement divided by the change in time. So that means that I'm going to have to take my finishing position and subtract from it my starting position. So I already know that I am 2,000 meters away from my house, and I'm going to say that my house is the origin of my coordinate system. This means that my final or finishing position will be 2,000 meters. And that my starting position would be 0 meters. So 2,000 meters minus 0 will give me 2,000 meters for my displacement. Now let's just keep in mind, what direction did I displace myself in? Well, it says in the problem description that I am walking to the west. So I can use west to be my direction. And I'm just going to make a note of that over here on the side, that when I get my final average velocity, west will be the direction associated with it. All right, as far as the time goes, well, it took me an hour worth of time to displace myself 2,000 meters, so that's what I will put in my denominator for delta t, 1 hour. So that means altogether that my average velocity is 2,000 meters per hour. But not so fast, because we still need to make sure that our average velocity is in base SI units. That means units of meters or seconds or kilograms or some combination of it. We have meters per hour. That unit of time, hours, not a base SI unit. So I need to convert my hours into seconds. Then I'll be done. So I'm going to take my 2,000 meters, and it's over 1 hour. And we're going to convert, so my conversion factor would be, I have 3,600 seconds for every 1 hour. And what this leaves us with is a average velocity of 0.6, and now our units would be meters per second. And if we wanted to just double check by doing a dimensional analysis, well, the units of displacement would be meters, and my units of time would be seconds. So indeed, my average velocity would be units of meters over units of seconds. Okay. So there we go. In its entirety, my average velocity for this walk with my dog would be 0.6 meters per second, and then of course my direction would be to the west. So there's a full example finding average velocity. The last thing I'm going to show you is, again, that velocity is not the same thing as speed. Just like distance was not the same thing as displacement. People love to say that speed and velocity are the same thing, but they are not the same thing. This example will show it. So let's say that we're having a race on a oval-shaped track, and we're doing a one-lap race. In other words, I'm going to go around the track like so, and my initial position will be the starting line. And since I'm doing one full lap, that means that my finishing position will also be where I started. And we saw yesterday that when we have this case where we start and finish at the same point, it means that our displacement will be 0. Well, let's look at then what our average velocity would be if we did exactly one lap on the track. Well, if my displacement is 0 meters, that means I would put 0 meters into my numerator. Okay? And we know that absolutely anything divided into 0 will give you 0. So it doesn't even matter how quickly or how slowly I run that lap. By virtue of the fact that no matter what, I'm going to end up where I started and have 0 displacement, I am therefore going to have an average speed of 0 meters per second. And when we have an average speed of 0 meters per second, this is one specific case where we really don't have a direction to associate with our average velocity. Because we didn't displace ourselves, therefore we don't have a direction for our displacement. So that's it for average velocity. When you come into class tomorrow, we'll go over any concerns that you have, and we will get back onto the probeware and explore a little further into what motion looks like when something is traveling and how we can find specifically its average velocity. So with that said, until next time, physicists, until next time.